find y prime for y equals this function. So do we use the quotient rule? Do we use the product rule? Do we use the chain rule? We have to determine what rule we're going to use. And if we can determine that one function was put inside of another, this function was put inside of a function machine that takes the cube root of whatever I feed it and puts that in the denominator of a fraction that has a numerator of 1. There's the outside function. What was put into this function machine is the inside function. So I would probably want to write this with a fractional exponent. It's going to make taking the derivative of the outside easier. And since I don't have any variables in the numerator, I could use the power rule to find the derivative of the outside. So y prime is the derivative of the outside. The power pops down front, and I reduce the power by 1. Negative 1/3 minus 3/3 is negative 4/3. There's the derivative of the outside. There we go. The first part of the chain rule. The derivative of the outside, not changing the inside. Copy down the inside function. Times the derivative of what's inside. The derivative of what's inside is 2x plus 1. So times the derivative of what's inside. There we have it. The derivative of the outside, not changing the inside, times the derivative of what's inside. And that is the derivative of y. This is the rate at which y is changing with respect to the independent variable x. Not difficult, you just have to know that notation. This is asking us to find the derivative with respect to x of this function. It's notation we haven't seen before. We'll talk about it in the next few lessons. But just know that those directions say find the derivative with respect to x of y equals, or f of x equals, either way, the cosine of 4x squared minus 7x plus 5. Is something being operated on? Why, yes. I have a polynomial that was put into the cosine function machine. This is a composed function, which means I have to use the chain rule to find the derivative. This is the derivative of the outside. The derivative of cosine is negative sine, not changing the inside, times, I could put a times symbol, I could put brackets around the first part of it, it doesn't matter. The derivative of the outside, not changing the inside, times the derivative of what's inside. If I were to see this as a multiple choice answer, that answer would more than likely be written like so. So there we have it. Several examples of the chain rule. These instructions say find the derivative of y with respect to x. Here is y. We know that y can be rewritten as f of x and vice versa. So I have f of x equals x squared times the square root of 1 minus x squared. That's a product. But when I do d2, 1 d2 plus 2 d1, when I do d2 in my product rule, I have something that's being operated on. d2 is going to require the chain rule. So as we saw when we learned the quotient rule, we had an example that had a product in the numerator. So in one step of applying the quotient rule, inside that step we had to apply the product rule in order to get d top correctly. The same is true here. In one step of the product rule, I'm going to have to use the chain rule to get the correct derivative for that piece of f of x. So f prime of x is 1 d2. Now it might be easier for me to write that as a power term. I can find the derivative easier. The derivative of the outside, power pops down front, reduce the power by 1. 1/2 minus 1/2 over 1/2, or 1/2 minus 1, leaves me a negative 1/2. The derivative of the outside, not changing the inside, times the derivative of what's inside. This whole thing is d2. This is what's inside. The derivative of 1 is 0. I copy down my minus sign, and the derivative of x squared is negative 2x. So there's 1 d2. I still need plus 2, which I can write in any form. You can write it in the original form. You can write it as the exponential form. It doesn't matter. 1 d2 plus 2 d1. There is the derivative of f with respect to x. It is y prime, which is what they asked me to find. Here's another one. Here is a chain rule with a quotient rule buried up inside of it. So we're going to, when we take the derivative of what's inside, that's going to require using the chain rule. So we take the derivative of the outside, not changing the inside, times the derivative of what's inside. Well, the derivative of what's inside is going to require the quotient rule. We have top and bottom. So we're going to include that in this piece because the derivative of what's inside is where the quotient rule comes into play. So we have bottom d top minus top d bottom over bottom squared. And there we have it. The derivative of the outside, not changing the inside, times the derivative of what's inside. That's the only calculus step in finding f prime. Anything else that we do to this is algebra. They haven't asked us to do anything with f prime, so we're going to walk away from it. The compound chain rule. What we've been dealing with is h of x defined to be f of g of x. What if we put h of x into another function machine? Let's call it j of x. Then that means we have h of f of g of x. Lots of compositions. That function was put into the f function machine. That function was put into the h function machine. And we're calling that result j of x. That is going to require the compound chain rule. And we find when we apply the compound chain rule, we just continue with our verbalization. We need to recognize outside and inside. And in the compound chain rule, we need to recognize that our first inside is going to have an outside and an inside as well, because we have a compound chain rule. Here, the very outside operation, the last thing that was done in this multiple composition, is that we had f of g of x, and it was put into the h function machine, and the h function machine cubed whatever we fed it. So the very first outside function is raising something to a power of 3. The inside function there, f of g of x, was the sine of 4x. That's what was fed into the cube function machine. Now we need to recognize we still have f of g of x. What is the outside function here? The very last thing done here is we took the sine of whatever we fed that function machine. And the inside function that we fed it was 4x. So listen to the verbalization for finding y prime. It is the derivative of the outside, not changing the inside, times the derivative of what's inside, which is another chain rule. So I do a restart on verbalizing my chain rule. The derivative of the outside, not changing the inside, times the derivative of what's inside. So depending on which derivative rule I need to apply, that and when I need to apply it, that is when I verbalize each piece. So I have common terms here. Again, if this was free response, we're done. If it was multiple choice, more than likely your answer is going to be listed in ascending order of powers. More than likely, this is what your answer would look like. It's just how we mathematicians do it. So the compound chain rule just means sometimes we have to do a system reset if times the derivative of what's inside requires another chain rule. And it does. So we look inside and recognize that outside function, don't change the inside, and then times the derivative of what's inside. So the chain rule shows up really, really, really often when we are taking derivatives. It's something that you need to know. Know that verbalization. By the time we get through working through homework problems, you'll have this verbalization in your head really well.